All right, so we are trying a few things today, so bear with me if the technology doesn't quite hold up the way that it's supposed to. I've tried it a few times and I've had some mixed things with it. So, yep, we're taking notes. So these are the kind of pre-sections to the book. We're going to spend today, Monday, Tuesday on them. And then we'll have a quiz on them on next Wednesday. Though most of these things you should have seen before, I'm not saying that all of them are going to be necessarily easy, even though they're in the pre-section, but they should be things that have at least some, like you've seen them at least a little bit before. So starting here, again, 0, 1, representing functions. Domain. Can anyone describe what domain is when we talk about math? So if we have a set of numbers, so like a set of coordinate pairs, right? What's the domain of that set of numbers? Or range? I'll take either one. Bell? Good. So yes, there are at least two different ways that we talk about range in math. One of them has to do with the difference between the biggest and the smallest number, or the biggest and the smallest number, and the range would be how far apart those two things are. That's not the range we're talking about today, but good. So the domain, there's a few ways we can talk about it. Sometimes we'll say that this is the input. Sometimes we'll call it the independent, is it ENT? I think it's ENT. Independent. But for today, more importantly than those, it's going to be x values of a function or a relation. Yeah. So x values then are typically independent and are typically our input values. That's not 100% always true because you can switch it around, but the x values is what we're looking for domain. Anything that we can put in as an x value into a function, or if we have just a set of numbers, then it is the x values of that relation. The range then, the opposite of all of these, right? So it's output. It is dependent. Depend. And it is the y values. Dependent. And again, most important for today is y values. Right? So quick example here. If we had the set of numbers of ordered pairs -3, 3, 0, -7, 1, -5, and 2, 4, our domain is the x values. The x values in an ordered pair is always the first number, right? So we have -3, 0, 1, and 2. Typically, no matter what order those ordered pairs are in, we're going to put them in that order. So increasing order from least to greatest. And then we have, kind of like we did with the range here, our y values, -7, -5, 3, and 4, right? For sets of numbers, hopefully this will be fairly easy to pick out. Once we start talking about domain and range of functions, it does get a little bit trickier. because we'll have to do it without knowing what the numbers are, and we have to imagine kind of what numbers actually work, right? But that'll be for later in the semester. Quadrants in the coordinate plane. You guys remember how we list our quadrants? Yeah, the top right one is 1, 2, 3, and 4. IV, right? 4. And what distinguishing characteristics of each quadrant do we have? So what's the distinguishing characteristic of the first quadrant? Good. Yeah, if we have a point, then it's going to be both points are positive. In the second quadrant, negative, positive. Third quadrant, negative, negative. It's like a sad face. And positive, negative, right? Just to be a little bit clearer than that, right? When we say negative, positive, we mean the x value is negative, the y value is positive, right? And just because I think we don't talk about it enough or at all, what quadrant would a point like 0, 3 be in? So the question is, yeah, so the main question that I'm asking here is, what quadrant is 0 in, right? Or is 0 positive or negative? No. So I think I heard someone say 1, right? Which would be probably the best guess. But is 0 actually in that quadrant? And the answer is no, right? So that is not in a quadrant, right? So we're not going to say it's in 1, 2, 3, or 4. We would just say that it's on the x or y axis, or we could call it an intercept, right? 0, 3 is an intercept for the graph. All right, good. I think the next slide is just the same thing. I just wanted to make sure that I covered all of that. So that's what we just talked about. I don't think we need it again. Representing relations. There are different ways that we can represent relations. We can look at them as ordered pairs. We can look at them as a table. We can look at them as a graph. We can look at them through something called mapping, right? All of these are the same thing though, right? So we have the point 1, 2, we have the point 1, 2, we have the point 1, 2, and we have the point 1, 2, right? And we could go through all of them. So these are different ways of representing the same relation for different ways. There are benefits to each of these, right? For ease of just like looking at what you have, yeah, Liv. It is not, but it is actually recording the. Yeah, I have the screen shared, but then they can also see me. I probably could just turn off that camera. It's one of the things that I'm kind of testing, but thank you. Yes, that would be extremely important. You kind of go from ordered pairs, which is probably the easiest to look at. Like, what do I actually have? Table is good at representing a lot of data, right? It spaces it out a little bit better. Graphing for looking at. And then the mapping can become useful, especially when you're looking at, like, if we had another point 1, 5, right? The mapping can become helpful because we would have a 5 here, and the 1 would also go to the 5. And then you see how that becomes a little bit more helpful than having another point here, 1, 5. Here you would see that the domain is going to 2 different things, right? So that's the helpful part about mapping. We don't do a whole ton of it, but there is a usefulness to it. My guess is that's the one you've seen the least of. Give you another 20 or 30 seconds here to finish up this part. Hopefully that's enough time. All right. So relations and functions. Relations is any set of numbers or any equation that can be given. A function then is a special type of relation in which each element, each number, each part of the domain is paired with exactly one thing in the range. So if you have a domain value, it can only go to one thing in the range. And we'll look at a number of these examples as we go through it. For this one, I think it's better to show a non-example. It's a little bit quicker and easier to see. So an example of a relation that is not a function would be like something like 1, 5, 1, 8. Right, and this might be a set of numbers, right? The set of numbers 1, 5, 1, 8, this is a relation. It is not a function because you have one value in the domain, 1, going to two different values, a 5 and an 8. Right? So this is not a function. Right? Whereas if you had like 1, 3, 1 set or 1, 3, 2, 8, 4, 12, right? That would be a function because you have different x values. So basically to determine whether or not you have a function or not, you're just looking to see if the x value is used twice or more than twice. And if it is, the only other thing you do have to check would be making sure they're going to different values. So if you had two that like both went to 1, 3, right? 1, 3 and 1, 3 is okay because it's the same domain going to the same range. It's just happening twice. But if they go to different ones, then it's out. Questions there in general on function? Again, we're going to do more examples. Yes. So as long as none of the x values are the same, then when we're dealing with a set of points, that's going to be a function. Yep. All right, so state, domain, and range of each function. Determine whether the relation is a function, right? Yes or no. So simply here, we're going to fill in our domain, fill in our range. The domain, again, this is another thing, and I'll let you guys know when I think things are things that we don't talk about enough in math. When we talk about domain and range, we're talking about a set of numbers. So this is a group of numbers that we're specifically putting together. just like this is a set of ordered pairs, when we talk about sets of numbers, sets of orders, pairs, you are almost always going to see it represented like it is here, which is those like funny looking brackets, right? Does anyone know the actual name of those brackets? No, I don't either. But those, the like squiggly line bracket, right? So that's how we're going to do these numbers as well, right? So we have a set of numbers. We're going to open this set. What is our domain? What's the smallest number in our domain? 1. Good. Next we have 2 and 3. Oops. And why is my eraser so big? I'll give you a second to fill in your range if you'd like. So the goal here would be to start with the smallest number of the range. And again, range, we're thinking y value, that's the second number in each ordered pair. And our range here is 6, 6, 7, 10. Do we have a function? Yes, good. All right, there is no x value that's duplicated, yes. Okay, yep. I will see if this works. I am trying to record it as I'm doing it, and I'll try to get it posted tonight. So hopefully you'll be able to watch it. If not, you'll just look in your book. You won't, I'll try to put in instructions for how to get to the homework as well, because it's not from the book. All right, second one. And you're going to do both of these first. Do that right? Yeah. The board's slow, and those are still much, much better than I usually do on those symbols. I think they're wrong, but that's better than I usually do. 27. And if I didn't say, try to decide whether you think it's a function or not as well. This might push it the opposite way. Don't think that it's not a function just because the first one was, right? Actually look at whether you think it's a function or not. Someone want to share what they got for domain? Yeah. -6, -2, 5, and 9. And how about our range? Jameer? -2, 0, 5. You're fine, right? You're not wrong. Oops. No, like I said, I don't know why my eraser got so big. negative 9. Was it negative 2? And do we think that's a function or not? It is a function. Good. And what's interesting, so if we were to write out something that's not a function for the domain and range, what you would end up having is the domain having less than less parts, less elements than the number of things that we have, right? So we have 1, 2, 3, 4 ordered pairs. If we have less than that in our domain, there's a good chance that we're not dealing with a function, right? The only way that's different is if you had like the point negative 6, 0 twice, right? You would still have a function even if we had another negative 6, 0. Let's pick one of these. I don't think we need to do both of them, right? So do we want to do 3 or 4? 3. So do 3 on your own. There is a nice part about tables with domain and range, I think, right? There might be a question you have about domain on this one. Does anyone have a question on the domain for this one as they're writing it? I already kind of said it, right? Does anyone know what question I think someone might have here? Yeah, Jameer. Good. So the question you might have is, do I put 1, 1, 2, or do I just put 1, 2? What do you guys think? We have 1 for 1, 1, 2. Agree? Agree? Anyone want to dissent? Zach dissents. Zach, do you have a reason why, or you just want to be the opposite of them? This is a 50% wrong. Good. And not necessarily for the right reasons, but Zach is right. It is just 1, 2. So here, as we're dealing with our set of numbers, we're looking at the set of unique numbers, right? Is 1 a different element than 1? Is 1 different than 1? No, so that's why we don't have to put it twice, right? It's the same number, the same element, it's the same thing, so we don't have to put it twice in our set because it already happened, right? In our range, 5, 7, 9. When looking at domain and range, you can kind of see why a table might be nicer. They might not always be in order like they are here, right? But the domain is just the first column. The range is just the second column, right? So there's an ease about it, about not even having to look at, like, getting confused about the set there. Do we think this is a function? No. All right. There are 2 domain values going to different range values, right? We have a 1 going to a 5, we have a 1 going to a 9, and that is what tells us that there is not a function here. We're not going to write it. What do you guys think? Function for the second one? Yes, right? Domain is just followed, right? Negative 12, negative 10, negative 8, negative 6. Range 0, 1, 2, 4, right? Let's again pick one of these to actually do. So let's just do 5, and then we'll talk about number 6. This one also, you can kind of see how the domain range part makes it easier, right? You can't get domain and range wrong on this one, right? The mapping literally breaks it into its sets for you. And sorry, you guys, again, this is new for me too, right? This is not how I've had my room set up for the last 4 years. So if I'm standing in a position that's in your way for too long, just tell me to move, right? You're not going to offend me at all. You don't have to raise your hand for that, right? Just say, Mr. Poppy, move. You can get pretty rude with that as long as I'm in a good mood, like as a joking rude, like I'm okay with that. Play it a little bit, like if it looks like I'm not happy for the day, probably take it a little easy. But like for today, if like Zach, if I'm in your way and you're like, Mr. Poppy, get out of the way, that's fine. Like, and then I'll be like, oh, cool. I'll just move over here because this is probably better for everyone, except that it's not better for me writing, right? So it's kind of one of those things where it's like, here's the best place for me for writing. Right-handed, I can see it without getting in my own way, but probably standing on the other side is going to be better for you. So just let me know, and I'll do my best with it, right? Kind of the same as if you were in my class last year, me not moving up the page as I was working, right? That happened a few times where I'm like talking and you're like, I don't know what you're talking about. You don't have it on the camera anymore. So if you watched my videos, you understand the reference. Yeah, but you guys all came from different classes, right? All right, the domain. What's the domain here? I'm okay not hearing the answer. I know you guys got it, right? And our range, oops, that's not at all how I told you to do it. And put that down. Right, I told you go in order, so we want -2, -1, 0, and our range is -3, -2, and 2. This, I'll do the show of hands, right? So just trying to see where people are. Who thinks that this is a function? Raise your hand. Number 5. Is 5 a function? Who thinks 5 is not a function? Okay, so this is that confusing part, right? The definition for function says, correct, if one domain goes to 2 range, right? This is 2 different domains going to 1 range. That there's nothing in the definition that says we can't do that. So this is okay. This is okay, and this is a function. The part here that actually we're not going to deal with today has to do with one-to-one and onto, which is something that we deal with later on when we come back to this kind of stuff. And then the second one, again, I know you can pick out domain and range. So is this a function? No, right? This has that problem where one domain goes to 2 different ranges. They're both about the same for difficulty, I think. So let's do the first one. Yeah. Yeah. Why this one is? So the definition for function says if one element in the domain goes to 2 in the range, 2 or more, right? It doesn't say anything about 2 in the domain going to 1 in the range. So that makes this okay, and that's why this one is not, right? This would be like the prime example of what the difference between the two is. 2 going to 1 is okay, 1 going to 2 is not. Does that make sense? I think we'll see it, we'll actually see it here, so that'll be helpful. Do we need any help with picking points off a graph? Or even just this graph because it's not huge? No? This one we can do at the same time though. What is our smallest domain number? -1, good. That is the point furthest to the left, right? The x value there is -1, right? The next x value of a point that we get is 0, and then 1. So we're -1, 0, 1, 1 again, right? 2 and 3. Range, our smallest range number, right, is -3. -2, -1. Sorry, I almost flipped over to domain there and thought I was doing stuff wrong. Then we go up to 2, 3, and 4, right? What do you guys think? Is this a function? No, it's not a function. So what we have is we have one number in the domain. That number is 1, going to 2 different numbers in the range that are being -1 and 2, right? So this number in the domain goes to both of those 2 numbers. If we looked at it kind of like a mapping thing, right? So 1 number domain goes to 2 numbers in the range. This actually, with the graph, actually opens up a whole nother way of determining domain and range that is actually easier. So I'm saying it opens something up about it. So it actually lets us see why this is not a function, right? So why is this not a function? There is a test not in like you're going to take a test, but a test that you can run on a problem that will determine whether or not it's a function or not. The test only works on graphs. Really, you could graph it and then run the test, but you kind of have to have the graph to be able to see it. And it's called the vertical line test. So if you hear vertical line test, what do you think the line looks like that this test is running off of? Vertical, which is straight up and down, right? So what this test says is that if I can draw a vertical line anywhere on my relation, that it crosses a second point, then it is not a function. So if I drew a straight line, I'm going to do my best. Ooh, that's good enough, I think. All right. If I drew a straight line, vertical line, right, and I move it across my relation, right? So I hit a point. Does it go through any other points at the same time? No. So there it's okay. Hit another point. Does it go through any other points? There it's okay. And if I had a slightly better line, right? If I had a slightly better line, it would be even clearer. But I hit this point, and at that point, my vertical line test fails, right? It fails because at one point, it goes, or at one spot, it goes through 2 different points. Does that make sense? So this is not because of that, right? You can also look at it through domain and range, but visually that helps. visually, that's why it's not a function. That's actually how we determine whether or not it's a function. That's the visual representation of the definition. Second one, do you think that this is a function? Yes, and the answer is because everywhere it does pass our vertical line test, right? It passes here, passes here, passes here, 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 and here. Never does our vertical line go through two different points at the same time, right? If there were such thing as a horizontal line test, there is, we're not going to deal with it, we're only dealing with horizontal, then number 8 would fail, right? That actually has to do with something that we'll talk about way, way later down the road. But horizontal, vertical line test, it fails. This is not, sorry, then this one passes, it is a function. Again, you don't have to write that one down. What are we at, 7 minutes, 8 minutes? Oh, this one's easy. All right, quadrant. Yeah. If you don't need to, you don't need to write these down, right? So this is up to you. 5-3 is definitely the first quadrant. 8-6 is the fourth quadrant, good. That's IV. 2-0 is not a quadrant. I'll put not. I'll look up what the book has for that. I don't remember what it actually says. And the last one is the third. Good. If you need the help, right, just draw your quadrants out, 1, 2, 3, 4, and plot the actual point. You can do that as well, right? All right, the last few minutes here, I need you to log into Canvas. I'm hoping that this will work fast enough. We will have homework, or at least that is the plan. At least some of it will be. Week 1. Oh, there you go. I guess I didn't need to freeze yet. And you're coming down here to the assignment 01 representing functions. And I am hoping by the time I made the Algebra 2 class do this last year, it was after we were online. So this may or may not work quite as well as I want it to because I never was on their end of it. Hopefully you can click on it and it will open up something. Yep. And can you press start? And I believe then it lets you automatically join my class. So it looks like it's working. Yep. Yep, and you can start it. There are a few things about it that should work well for you. One is that it will tell you right away whether or not you're right or wrong. For homework, you are able to continue to redo it until you get it right. So this is the homework, yep. It will let you keep working on it until you get it right. If a question just isn't working for you, you should be able to load a new question. It may, after 3 times of getting it wrong, make you choose a new question, make you redo it and go into a new one. I can't remember for that for sure. But basically, you should have the opportunity on every homework to get every problem right. And if you aren't, right, if you tried it like 2 or 3 times and you're like, I just can't get it, then it's something we need to work on still, right? So it becomes much more obvious what you need to do so that, or what I need to do to help you as well. All right. Looked like it was working for everyone. Is that what it says? Then yes. Is that how it's set up? I might need to make adjustments on it still for other ones. I think you can just submit it at the end. The submit throughout is just like a save process. So like if your computer crashed, it might not save it if you haven't submitted it. But the submit will also let you check, right? So if you press submit, it's going to tell you whether or not you got it right or wrong. And then you should be able to change it if you got it wrong. So if somebody wants to try that, right? Did it let you redo it if you got it wrong? Yeah. So this is what the first at least 3 assignments will be on, plus the quiz. And because we will use it some at least. I haven't decided if I have, it takes a little bit of time for me to set up. So there is some issues there. I think we're done with the screen, and hopefully people already stopped listening to the recording if they were on here.